And now we're going to be at the last possible move. We'll move one step closer to the mirror. And this one is really tricky if I stay 2 units high. So I'm going to shrink it down a bit, and I'm going to go 1.5 units high. I can still do parallel quite easily because I can do parallel very easily because I can just hold the control key down here. So I've got to give myself a bit more room up top. I'm going to pull this down a little bit here. And this one becomes more trick shot than anything, and I'm not really fond of these diagrams as a result. I'm not sure how much you're learning. We've got 2 trick shots here. The first trick shot is the one we've tried on 2 previous ones. That is the line in which you can see the gray path is following a radius. So any light that goes from this tip out to the rim on this trajectory will turn around and go right back where it came from. So the light will shoot off this way. This is why seeing one of these finished diagrams is useless. You need to be part of the process. But now we can do another trick shot. If I go to this color here, we can do it again with this point now. A beam that goes in on this trajectory. So it looks like it came from the focus. Okay? Would now exit straight parallel that way. Took off like that. And the third beam is the one that went straight in, and then it took off through the focus like that. Every now and then someone will say to me, but how could it do that? Wouldn't it hit the object on its way past? Not really, because the mirror has width. We're looking at it on flat. So yeah, some parts of the light bouncing off a mirror get hit by the object that's in their way, but there's plenty that go around it. Remember, the mirror is circular in profile. We're just looking at it on edge. Now, at first glance, you go, wait a minute. There is absolutely no way these beams are coming together. They are spreading apart. So there should be no image. But there's a little trick here. Follow them backwards. Okay? Once again, this line and that line are not joining. But you know they will. They join up here somewhere. There's an intersection that is unspoken, but it's there. And that's how you can draw choo-choo train tracks. You want them to vanish in the distance. It's a classic old vanishing point. Okay? Do you not see the vanishing point on these 3 lines? If you follow them backwards, your brain, so smart, even when you're feeling dumb, your brain will backtrack these rays and go, you can't trick me. I know where this light came from, and your brain follows it back like that. Well, we want those colors to match, don't we? Goes back here. I should have made that one in red. Let's fix that. So we'll go back to the nice bright red. Go it that way. Then we'll go to this color, follow it back, and then go to my green. Remember, I'm colorblind. Give me a second. Is it that one? Let's see. I thought it looked the same, but now I can sort of tell they're not. Anyway, you get it. Let's just fix that up there. There we go. Okay, so real light, not real light. But your brain definitely thought it came from back there. So let me clean this up. There's the virtual intersection. The light seems to be coming from behind the mirror. Now, this light behind the mirror, I've got it in color. Most of the time, you should switch it to dotted lines because there is no real light behind here. But now, what your brain has seen is a giant enlarged image on the other side. So this is the way you normally see a makeup mirror. You go really close to the mirror, far closer than you should, and the mirror shows you a right side up version of your face enlarged, so you can see all the flaws in your skin that not a single other human being can. So smash your makeup mirror now. You don't need the things. They're terrible. And you get this giant right side up view. So if you were to simply back away from your makeup mirror, you would find all those wonderful upside down images we have in class. Just your home makeup mirror, you need to be back a couple of meters before it inverts it. But please don't stand so close to those mirrors. You don't need to inspect yourself. You're fine the way you are. That's my little thing in there. So how do we describe salt now? Salt is easy. The size is huge. The attitude is upright. Its location is behind the mirror. We don't have to talk about distances or anything. It's just behind. And the type is now virtual. Why is it virtual? Think of the letter V. V is made up of spreading rays. The real beams of light are V'ing off into the distance. This means a human brain can follow these back and see an image. But in real life, the light from this arrowhead has actually been scattered all over the place. And the light from the tail and everything is just being thrown everywhere in the outside world. And that is not the recipe for an image. It's a recipe for a blur of light. So it is not projectable on the wall, but if you stand in the way and you put your eyeball to work right here and you look, your brain will undergo fantastic calculations on the small scale. With your eye, your brain will sit here and stare at this and make sense of it. But the projection screen is just being hit by random beams of light from all over the place. They're not in any particular pattern, and you cannot project it. And that's what makes a virtual image. The image you see is on the non-existent side of the mirror. Okay? And this is one of the hardest ones to draw of all, so you should practice it.